Nice to see all of you here in Bolzano in Neue Tech Park. Good afternoon, everybody. My name is Peter Leibengut. I am consulting engineer here at Neue SPA, and I welcome you to today's seminar on textile innovations and sustainability. A seminar brought to you or co-financed via the ERDF fund of the European Union, for which we are really grateful. Therefore, I mention it directly right from the beginning. Our objective here at Neue is to boost research and development, business innovation, and we try to impact directly on our region, here at the heart of the Alps. So we try to stay on top both on the thriving technologies which drive here everything regarding to the development, and we try to stay on top on the needs of the territory. Therefore, we invited you today to this topic, textile innovations. Neue is the place for cooperation, for innovation and engagement. And we are happy to bring to you today's event in order to broaden your knowledge on textile innovations and on sustainability, because this is, I think, the backdrop on all the topics, not only regarding textile, but everything in manufacturing now goes into that direction. And you have the opportunity to meet lots of people, maybe like-minded, maybe interested in the same topics, to enter into discussions and maybe develop some kind of joint projects with each other. So, use these opportunities today. Before we kick off the event for real, let's have some words from our Vice Director of Technology Transfer in Innovation Management, Vincent Mauroy, who would like to say some words to you today.
Thank you, Peter. Thank you, everybody. Welcome, everybody, to that event. So, like Peter told, so that is one of the services that we have is called the Know-how Transfer event. So we are linking people together, science, company, startups maybe sometimes, and also experts to have new insights, to know which are the new best practices and to push innovation and research and development. This is why also we do that. We have also a lot of other services that I won't go into detail now. Important for us was already since a long time textile. So, for example, we are working already a long time together with the Textile Competence Center in Vorarlberg. That's only one example. They are also present and they will also present something. But at the end, textile, there are a lot of textile companies also here in South Tyrol. But I think also textile is maybe something that is sometimes underestimated. Textile is everywhere, of course, in our clothes, but a lot in buildings, a lot in vehicles, and a lot of other applications. So we can impact a lot by innovating and doing special things related to textile. And unfortunately, textile doesn't have a very good reputation so far. Only considering Europe, it's on the fourth scale, so number 4, in the negative impacts on CO2 and emissions and so on. So that is also something that we have to work on, as Neue Tech Park, as you know, has a very big focus on sustainability. So innovation is one thing to make our products more attractive for the new market or for new features. That is, of course, a very important topic, like, for example, making smarter textiles. We have already a lot of examples here. But also providing solutions to render our textile more sustainable, both in production, in usage, and after usage is also a very important focus that we have. So yeah, those are very short introduction words from my side. So enjoy the venue and and come to us, Tech Transfer, in case you need some help and services to push innovation and R&D. Thank you.
Thank you, Vincent. So let's kick off this afternoon with our first talk from the very Textile Competence Center Vorarlberg. Please welcome together with me Professor Tung Pham from University of Innsbruck, Dornbirn. I should say precise, please. Professor Pham earned his PhD in Germany and then took on work as a research chemist in the innovation headquarters for the polymer producer Borealis in Linz, Austria. After 15 years of research there, he switched to a professorship he received in 2014, and in 2016 he received his professorship at University of Innsbruck, where he now heads the Institute for Textile Chemistry and Textile Physics at Dornbirn. His main interests are textile and polymer chemistry, surfaces and interfaces in hybrid systems, chemical recycling, and textile circularity. And I think that's the very point why we invited him today. So, Professor Pham, the stage is yours. Thanks for being here.
Okay, good. Thank you very much, Peter, for the introduction. Thank you very much for organizing this event and give me opportunity to share a little bit what are we doing as a research institute on circularity and sustainability. I just introduce our institute. It's part of the University of Innsbruck, and just very few facts about our institute. So the institute is founded in 40 years ago, and the main reason for having founded this institute in Dornbirn, which is not Innsbruck, to make you aware of, Dornbirn is 200 kilometers far away from Innsbruck, is that to support research and development activity in textile industry, which is located heavily in Vorarlberg. As said, we are part of chemistry and pharmacy. Okay, this is, oops. No, this is not what the pointer. It works? Okay. Okay, thank you. Perfect, thank you. So, the number giving you here, it's, let's say, the most recent number, and just to make you aware of the history of the institute. So we have started with 3 persons in a classroom. And over the 40 years, we have involved now in the full institute, serving education, trainings, and of course, research. Now let me move directly to the subject of today. Why are we now keen on doing research on textile circularity and sustainability? I think we already heard, textile is now one of the enemies in the sense of providing in the sense of negative impact to the environment. And let's have a look in the fiber production and production of textile. As you can see here, if you look a little bit on the development of fibers, or let's say fibers produced for textile over the last decades, you see we have an exponential function of increasing. And if you count, the other thing is that we have 2 times increase of the average number of the time a garment is worn. That means that while significantly increasing the volume of the fiber produced for textile, we use our textile less. So we buy more, but we use less. So this is also the essence of fast fashion that we have today. And it leads to the situation which you already seen more or less on the public television, on social media, and so on and so forth. This is a very, I would say, touching picture, for example, from a desert somewhere in Chile. The same picture you can find everywhere, also in Africa, in Asia, in my own home country in Vietnam. You see it everywhere. Every time when I went home for a visit, I saw it. And the problem we have it here is that everyone is talking about circularity. And what is then, are we circular? In textile, my answer is no, we are not circular, we are linear. And if you look into the study provided by the Ellen MacArthur Foundation, as you can see here is that this is the number, please pay attention to this number. Less than 1% of clothes is recycled in circular, meaning from fiber to fiber. This is less than 1%. The majority, the majority of what we have bought and ruined just twice, end up in landfill or pollutions. This is the reality. And very, very small part, of the feedstock is coming from the other sources. And this is the percentages, as you can see here, if you are going now to a shop and buy some new clothes. And if it says, this clothes is made from recycled polyester, it comes from here, more or less. More or less come from here. It comes from bottles, not from textile fibers. Very few companies, very few projects try to recycle from fiber to fiber. The majority either end up in landfill or coming from other sources. So meaning that we are not circular. And this is the problem we have. And next to that one, we also have very, very complex material composition when we are talking about clothes. And my colleague from company can prove it, because if you look into your typical sport textile clothing, running shirts, the tights you are wearing for shoes and so on and so forth, they are not made from monomaterials. So at least they're consisting of two types of polymers, either polyester, polyamide, or in the other case, could be regenerated cellulosic fibers or cotton, but for the time being, they almost contain elastane, for example, which is a polyurethane. So it's hardly to buy a jeans without stretching functionality. Okay, the other challenges we have it here, I reported already. We have fast fashion, we have linear pathway of clothes, we have rather complex material composition, we have mixture of fibers, we have also dyes, we have additives. So the majority of our clothes are dyed, and we have additives in that one. And for the time being, we don't have any standard labeling of our clothes, and we also don't have the state-of-the-art in sorting. Please don't trust the label you see on your clothes. So we have received 2 pieces of running shirts. In one, they are identical, we know it. They are produced for the same company, having different labels. One stands 100% polyamide, other 100% polyester. So we can trust one or the other. This is the situation we have for the timing. These are the main challenges in textile circularity. Okay, now when we are talking about recycling, we try to convert textile into textile again. And in principle, we have, let's say, a few methods in order to turn fiber into fiber. Typically, we have mechanical or physical processes, and next to chemical processes. In mechanical processes, we are talking about sorting, cutting, shredding, and sometimes we have melting. So we are molten. We do melting our polymer into the new fibers. On the other hand, we have the chemical processes where we have, for example, depolymerization, meaning that we break the polymer chains into small monomer, and when we repolymerize it in order to make a new polymer. Apart from the chemical recycling, we do have chemical separation and recovery. And the entire thing, you can see that if you are talking about the entire production from the polymer to the fiber, spin of yarn, weaving, knitting, clothing, we have several approaches in circularity. Of course, we have the energetic recycling. We burn it and we get some heat back. We can have some kind of, we change it, release it, or we do some kind of textile recycling. We collect clothes, we make it, we try to produce some of the rags for cleaning. But the main part we are talking about, or we are interested in, how to convert a fiber back to the fiber for the same cycle of producing one piece of textile product. Okay, now this is the slide I just want to show it to you when we are talking about different ways of recycling. Again, we don't have any standards in definition for textile recycling technology. Most of the techniques available for the time being only fits for monomaterials. I touched the point of having this mix of fibers. And we know that to some extent the mixed components work as contaminants. For example, if you want to recycle running shirts having more than 5% of elastane, it won't work. The fiber spinning process will be deteriorated. We don't get a nice fiber out of product having more than 5% elastane. So you have to eliminate it somehow. Now, there are some level of textile recycling for different materials. We are talking about cotton here. We are talking about regenerated cellulosic fibers such as lyocell or viscose, as you know. We are talking about wool, polyamide, which is known as nylon, polyester, and also polyurethane, which is more or less known as elastane. From fiber to fiber, natural fibers, yeah, we can shred it, we can use it. We have some problem here because the fiber will be shortened during recycling process. They are not suitable to use it too many times. Wool, yeah, we don't have any other choices than use the fiber as is it, because we cannot regenerate wool. But then when we're looking a little bit on the cellulosic part, yeah, we do have some processes which can be applied to reuse, for example, waste cotton to regenerate new fibers. So processes are available like viscose process, or most recently using ionic liquids, for example. Our focus is more on the synthetic part. How can we recover synthetic fibers, polyester, polyamide, and polyurethane? For that, we have several approaches. So you can do fiber-to-fiber recycling. We can do polymer-to-fiber recycling. Even here, repolymerization, it is also available for nylon and for polyethylene terephthalate, but not for polyurethane. So polyurethane is spun using solution spanning, and there's no way to recover and to re-span polyurethane for the time being. It's not existing. So this is the state of the art, actually. Okay, what is our approach? So in the last, I would say 5 years, yeah, so we have been working on the way our philosophy is to focus on the selective dissolution, separation, and recovery of the major component and eliminating the minor component. So we have been working in two main polymers, nylon and elastane. So in one project, we try to separate and recover nylon from a mixture of nylon, for example, with cotton, with polyester, or for example, also with cellulosic fibers like lyocell or viscose. In other project we started 1 year ago, we have been working on the selective dissolution and the recovery of elastane. This picture shows you a knitted fabric having elastane, yeah, core, and outer shell. It's consisting of several polyamide small fibers. And using two different techniques, here in this example you can see we could isolate elastane fibers by dissolving the polyamide outer fiber. And if we use our other techniques to solve polyurethane core, you can recover the outer part consisting of polyamide fiber. Let's move now to some of the example. Now, the example I have been talking is a typical yarn you can see here. Many companies use it, yeah, for tight, for running shirts, for clothing. They have multi-filament elastane, and they have the shell layer out of nylon polyamide. In many cases, 6 or 6/6. So under trade name, it's known as Roika, spandex. What else? Yeah, spandex, Roika, and lycra. Yes. Okay. Now, what happened is the following. This is the first example. Again, yeah, you remember I showed you the fabric before, the knit fabric before, and the fabric after the solution of nylon. And let's see if the movie worked. Yeah, we try to dissolve polyamide at room temperature. The picture shows you that the shell made of nylon just disappear away. This is the microscopic recording having 10 times speed at room temperature. Okay, so the basic principle of this technique is rather simple. So we know that polyamide, for example, here in that case, polyamide 6/6 or nylon 6/6 have very strong hydrogen bonds between the polymer chains. So this is something we call intermolecular interaction between the polymer. And we use a technique which is we call it complexation. So we complex the oxygen atom here with a calcium, and the calcium complexation disrupts the hydrogen bonding between the polymer chains, and the polymer chain become loose. So it's moved away from the fibers. So, and then by doing the opposite way, which we call decomplexation, just washing away the calcium, we could complex back the polyamide. So mean that we use this technique to dissolve polyamide, at the same time we get back the polyamide as powder. There are a few examples I want to show you here. This is something we said, okay, this is a mixture of wool. This is the wool we recover after this solution. This is the polyamide you can see here. And this is the wool structure. Typically, after dissolving the polyamide, you get back the wool having still some traces of polyamide. This other example on polyamide with cellulose. You can see here, this is the cellulose fiber. This is polyamide 6,6. And after dissolving polyamide, you get back the cellulosic fiber having still some residues. This is a very nice example here. This is a knitted fabric again, having polyurethane core and polyamide shell. The problem here is that if we would just dissolve polyamide and recover it, the structure of elastan just hold everything together. So it's some kind of clumps between your netted made of polyurethane. The second approach we are using here, we use the same example again, but then the next example I want to show you here is that we try to dissolve elastan out of the fabric. So this is the fabric before. After having elastan dissolved, you can see here there's no elasticity existing any longer in the fabric. So we get a loosened polymer structure. And this is a video I would like to show you here again, using our developed solutions. You can see here the core just like dissolve away. This is at room temperature by 8 times recording speed. So polyurethane completely dissolved. Okay. Okay. Again, look a little bit, have a little bit closer look into the structure. You can see here, this is the core of elastan, and you have the polyamide fibers outside here. And after the first dissolving step, you can see some elastan still stick to the polyamide fiber. And if we do the solution one more, you more or less get very nice and clean polyamide fiber back from this fabric. So we have extended also our experiment now to other systems of polyethylene terephthalate, of polyamide and viscose. So which we did here is the following. We try to dye the whole system using typical dyes. For example, we use this first dye for polyethylene terephthalate. We use metal complex and acidic dye for polyamide, and we also use indigo for viscose fibers. And we mix it in the different mixture with polyurethane, 10%. Using the same concept, we can dissolve more or less completely polyurethane, but then, as you can see here nicely, you get the dyed fiber back. So this is the state of the art as we have been doing. However, the challenges remain, which is our focus for the future. So we have two main aspects which we have to consider in the future research. In the process part, we need to think about process engineering, how to design the dissolution process in the industrial scalable way. That's part one. We also need to work on solvent recovery and refinery for solvent recycling, because we cannot just throw away the solvent. We need to recover and reuse it. On the material aspect, we need to look on the polymer degradations during our dissolution and recovery process, and we also need to look on the interaction of dyes and additives during the dissolution and recovery process. Is the dye stay active? Is the additive stay active? Do we need to top up the colorants, or let's say the color, after this dissolution and respinning? And it helps us to follow the approach of fiber to fiber recycling. So meaning we want to go from the end user, meaning that we are talking about fiber waste, and we would like to go back to the fiber waste. So we try to reduce the downcycling aspect. We try to reduce the energetic recycling, and we want to increase this fiber to fiber recycling approach, knowing that we still have a lot of challenges the way ahead. Thank you very much. That's all on my side.
Thank you very much, Professor Pham. I think we have ample time for discussions and questions from the audience. So if you want to ask some questions, please show of hands and we can directly continue. I will fetch you one of the microphones.
Thank you very much for the nice and interesting presentation. In one of your first slides, you also mentioned the potential of recycling on the monomer level. Mm-hmm. Are there practical examples of this? And is it worthwhile doing it, going back to the monomer, because you need a lot of energy to go from the polymer to the monomer?
Yes, there are very good examples. I think there is Aquafil, there's a company in Italy. Yeah, so they depolymerize fisher nets. So they use they collect fishing net and they polymerize it into monomer and they polymerize it into fibers. Yeah, that's a very good example. Yeah, how to utilize polymer resources. Yeah, to make new polymer, going through the step of depolymerization and polymerization. Of course, I haven't seen any energy balance calculation for that one. That's part one. And part two, no one talking about monomer purity. So having spent 15 years in polymerization industry, I know how the monomer purity could kill the entire process. And this is something we have to consider, because if you are thinking that we are collecting waste, yeah, and we depolymerize, we have a lot of impurity. And in order to ensure that we have a high quality polymer, we have to ensure the refining and the cleaning process of the monomer. And if you sum it up all together, depolymerization, yeah, cleaning, refining, and polymerization, I don't know how far we end up of the energy consumption. This is something I would say I'm not in favor of following it up. Yes, it's one of the options, but I would rather try to not to do that. Let's put it that way.
It's one of the routes with less potential, maybe. So it's better stay on the polymer level, or even better the fiber level.
Yeah, yeah. So
thank you very much.
Trying, let's say, minimizing the steps in between. Let's put it that way. Yeah.
Next question.
Yeah, I'm curious. You said that you solved the polyurethane out of the fiber
yes.
blend, and then you gather the fibers in their original state, as I...
Yes.
Have you already tried how to recover them into the textiles again? Or is this still at labs? Yeah, you said it's at lab scale.
Everything's in lab scale, yes.
But there is a potential to gather the filaments, if they are filaments or staples, and then to work them again into the spinnery and to create textile.
That would be the ideal case, yeah. But I fear that I showed you one. Oh, sorry. Okay. No, the problem is the following. If we take the example.
It will be coming on in a second.
Yes, I saw it over here. Yeah. Let's take this nice example. Yes, let's take this nice example. Yeah. So for that example, we dissolve the elastin core and we get the polyamide fiber back. Now the problem we have here is the following: the fibers are still forming a very tight network, and if you want to use the fiber as such, yeah, to spin the new yarn, first we have to take it away to make the band out of it. And for that one, for sure, you will cut off the fiber.
So you need to fiberize. So mechanical process,
exactly.
and then to see how it processes.
The fiber mechanically, and using mechanical separation, you still destroy the fiber structure and also the length. So we cannot retain the entire filament as such. So meaning that the direct recycling from fiber as such, to move into the fiber as fiber, I think is so rather limited. I would even think that this one is best suitable for the re-spinning process using melt spinning. Yes.
Oh, okay.
So to use it directly as fiber,
And this is polyamide 66, right?
like some is, yes. Yes, this is polyamide 66, but it also works for polyester, and it works for mixture between viscose and elastan. Yes.
And the elastan is then blended into the solvent? It's
elastan,
mixed
yeah.
into the solvent at the moment. It's
I don't
it's like
have the example here, but the trick is very simple. Let me show you. The principle is very simple. So we use a solvent blend. Yeah, so we have two solvents, we mix them together, and having a specific ratio, the solvent blend solve elastan. And as next step, we evaporate one. Okay, and in the other step, we evaporate one of the solvent and we shift the solvent ratio, and then elastan precipitated as powder. So this is the process we are using. So we don't wash it, but then we just remove one of the solvent partner, moving away the solution capability, and then elastan just precipitated. And then we put back the destillated solvent to the new process. So this is a process we are working on. That's why I'm talking about process engineering. So this is something we are working on. So we don't throw away the solvent, we reuse it.
Thank you.
Okay.
Further questions?
Okay, thank you.
Make a quite hard switch from perspective. We heard lots of information about the chemistry or the intricate mechanisms taking place when trying to dissolve those chemicals. And now we want to see how would, let's say, industry take these approaches on, and what kind of possibilities would industry see in using and reusing textiles or sporting gear, for example, if we stick to this topic. Therefore, join me in welcoming Martin Strehler from Sportinnovationsnetzwerk Deutschland, who is trying to give us the perspective of the sporting goods industry on how to use materials again and what kind of concepts they, as the sporting goods OEMs, would have in mind. So please, Martin, join me on the stage. Martin works for Sinnnetzwerk since 2000, if I'm right?
Innovationsmanufaktur, yes,
Yeah.
Since 2000, and for more than 10 years for the SIN network.
Okay. And he did his studies in sports
Sports
sciences,
yes.
right, at Technical University of Munich, and developed a garment for ESA astronauts, right?
Somehow, yes.
Optimum. So, join his talk and try to make up some questions after that, and we are eager to see what, let's say, the take from sporting industry would be.
Thank you so much, Peter. It's nice to be here. My name is Martin. Like he said, I'm a co-founder of Innovationsmanufaktur, a think tank based in Munich. And I'm happy to talk a little bit about the industry perspectives from the field of sports. So I cover a little bit about the network, what is the network about, the Sports Innovation Network, and some inspiration from our networks and some external inspirations from the sports industry, and give a very short outlook. About us, so we, like I said, we're based in Munich. We founded more than 20 years ago, and we're a spin-off of the Technical University of Munich. And we have our own innovation methodology, but we did not always talk about innovation, so we really wanted to be close to the users and make innovation happen. So we are considering ourselves also a bridge between science and industry. We have several main focuses. One is sports and health, and there's also the partners of our Sports Innovation Network. We conduct several of these networks where we connect the people and do some networking and try to get innovations on the road, also via research projects or directly industry projects. So, for example, we started with some bio-inspired safety systems. This is a project we set up where we had a look at bionic principles for safety gears. We have some network trips, so we have been to Bozen, I think more than 5 years ago, and had a nice meeting here. And like I said, we are managing several networks, also an elite sports network, where we take some insights and can transport elements and do some trend scouting. So if we start with some innovations from the textile industry to start off, is we developed preventive orthesis for the skiing athletes against ACL ruptures, and it was a quite rigid structure, and it worked excellent, but the acceptance of the athletes was medium, so sometimes if they had problems or if the topic of knee injuries rose, they really used also this preventhesis, we called it, but afterwards it would also decrease, and that's why we are for a few years already now working on a textile-based structure that should prevent cruciate ACL ruptures, but it is quite difficult because the knee or the body is such a complex building, and it should only give the total freedom of movement, but only in case of a rupture it should protect the athletes. One totally different innovation approach is with a German Institute for Textiles and Fibers. There's some sensoric elements in this training band, and we use it for several training methods, but also what's the great thing is for gaming. We have a network that's called Physical Esports Network, and there we're creating games, or we're creating sports and gaming content, and then we mix it together that the people or the kids not only play on the computer but try out moving or really applying force. Here in this band, you really can measure the force or apply force and take it for gaming. A very crazy idea. We started with BASF more than 10 years ago to developing alternatives to snow. In the beginning on a polymer basis, and but on the one hand it was quite difficult to get a good substance that's for a gliding substance like snow. And on the other hand, we then said, we do not want to have all these chemicals in the mountains and not even in the city. Like there's the air and style, for example, in Munich. There it has been the air and style, and now it's vanished because it takes so much energy to bring the snow there and conserve it. So we worked on this project, biologic options. And we had a 3-layer textile, and on top of it we had an algae-based basis, and this was providing a very good gliding surface, gliding options. And what's also for skiing, what's quite difficult, is to giving also the perspective of carving and give you good turning possibilities. And this is unfortunately only a feasibility studies, and we are waiting for more investors or the partners to take it a step forward, but I really like this project. Also with the Textile Institute, they're developing carbon fibers, bio-based fibers from lignin. This is something from paper production industry, And for example, our partners from Head Racket Sports are quite interested in these organic carbon fibers. And I will skip the thing on the right-hand side, not to tell something from our next speakers. But a totally different perspective. There's a bob's track in Königssee, and it was washed down by heavy rainfall, so it was the upper part was completely destroyed, and then it will take millions to build up something like this bob track facilities. And then there was a real question, is this still on the pulse of time to build something that's not really sustainable? And so we had a lot of pros and cons, and so we had a very nice workshop there, and got all the partners together to build the most sustainable bobsleigh track. And what I learned, well, one very short story, is that also the nature partners are often not on the same page, because on the one hand we wanted to do it climate neutral, so you need a lot of cooling for getting the ice on the whole winter long ready for the sports. And if you listen to this party, then you put everything with solar panels. You encapsule the structure so the cold stays in, and this was totally contradictory to the nature parts. We say we don't only want wood construction; it should blend in the nature. So we had some hot discussions, but in the end, I think we're on a good way to also get a new bobsleigh, bob track for the partners there. For more than 20 years, I'm at ISPOR, and I'm also having like I said, the trend scouting parts from the sports industry. The first thing is on the left-hand side is, I think, is the most innovative. The degrowth thing is what I heard in France is the topic. If our ecologic sense is always produce more, get this new jacket, buy these new skis, then we're not on a real sustainability track. Well, because we're trying to convince the people to buy always new stuff, they need a new jacket every year. So the logic consequence would say, don't buy this jacket, repair your skis, give it a second time, lifetime. And this is quite a big contradiction to what our industry standards are now. It's always about growing and making more money and expanding and selling more jackets, more garments, more sporting goods. And in this outdoor community, also there are a lot of thoughts already on could we skip one time and say, okay, there's only jackets every 2 years or gear every 2 years. And this would be a big step forward in real sustainability. One quite crazy example I also brought here is the thing about what they say, Polychain. They add some materials to the garment, and then the odor is not or it prevents from stinking and then producing odor. So you could use your garments, sport garments, several times before washing it once. And that's quite strange for us to say, oh, I don't want to go with a sports t-shirt for a second time. But if you think about the environmental impact, I think it's so nice that if you think about, okay, you need electricity for the washing machine, you need washing powder, you need the colors will decrease if you wash it so often. So it's a quite nice perspective, I think, or sort to broaden your mind and see in how many perspectives you can think about sustainability. So this is all more the more or less common approaches to use less resources, to use regrowing resources, use less energy, use less plastic, use less logistic and storage. I think Orthovox has quite a good portfolio also of sustainability measures or actions. For example, they're quite well known for the merino wool, but they also have this kind of second life shop where you learn how to repair your equipment. And also in our times when Amazon, you can say, I just buy stuff, and if doesn't fit, I send it back. I think this is a wrong signal in terms of sustainability. So they're saying if you buying something in the shop and you do not send it back, then they already gain some money, and also it's good for the nature. They donate some money to a philanthropic fund. So, like I said, in this more than 20 years of ISPO, I saw so many approaches coming to the sports industry, also in terms of sustainabilities. I don't know, I've seen more than 10 companies trying to establish a wooden bicycle, a bamboo bicycle like we have here on the left-hand side. We saw a lot of skis made of materials of wood and so on. So there's there have been these approaches to use more wood and natural fibers for a longer time, but then now what's also coming is the overall strategy that's changing. We have the first circular economy sock that is made out of socks. I think it's quite nice, and but also in different other parts of the sports industry, where normally it's always going about with oil and plastic. Here, this hose sports doing water skis, they just switch from this oil-based to a microalgae oil and did a bio-based foam that's quite lightweighted. When I've been in the ISPO award jury, I was quite impressed about the Alpino vest because it's just used wool as a damping function. So they have several layers in the back as a protective gear, and the vest is totally made of natural materials. And I thought, well, normally if I think about back protectors, it's all plastic, and then I thought, is it quite nice? Same way to think about what I put on my body and what I use for wearing, and also it's quite breathable, good for sweating and for warming. So I like this approach, and only that this is a very recent sustainability award from ISPO that also not only clothing and outdoor industry really thinks about other perspectives. The diameter surfboard is completely reusable, so you can disassemble it and reuse all components. That's quite unique for industries that always used composites and plastic materials, let's say. And a short outlook, what we also would like to work a little bit further in the future in terms of sustainability. If you think about the possibilities of additive manufacturing, if we see on the left-hand side, if we have a local just-in-time production to additive manufacturing, then we have less logistics, we have less storage we have to do, and less overproduction, so less waste. If we think about the possibilities to making sporting goods more modular, then we could also exchange broken equipment. We can exchange outdated stuff, or even for kids, if they grow, we could perhaps put in some new modular parts that can, so the sporting goods grow with the kids. And I think that we need sustainable fibers or materials for this process. I think there are some experts perhaps in the room, but these are more or less some thoughts from myself and from my Sports Innovation Network, and I'm really happy to discuss with you some thoughts in this field, in the field of sports. Thank you so much.
Thank you very much, Martin. Any questions from the audience? There are lots of concepts, let's say, skirted, so you can make up your minds and bring up your own ideas to the stage. Du hattest keine Fragen, Jakob. Ja.
Thank you so much for your speech. It's really great to see how different kind of environments or different kind of devices is put in for this kind of textiles and yours. I would like to ask you about this alga or this this product of alga to try to emulate the snow conditions. I don't know if you make some kind of experiments concerning, for example, for the rheology or for the tribology conditions. Tribology condition. Tribology.
Sorry, I'm not so deep into this project. I did not conduct it. Can't say too much about this. So, but what I say is it's quite good also for the carving possibilities.
Okay.
But I can give you some context if you want.
Yeah, I'm interested. Okay, thank you.
Any further questions? If not, maybe how do your contacts interact with each other? So you're working in workshops, as you have shown to us, but are there controversial discussions on these topics, or are they more unisono in the direction, we need to make more money? What's the gist you can observe?
No, normally we bring up some really crazy topics and find also some controversial opinions, and then we sit together in a future evening, like we call it, or on a networking trip, and then we talk about topics like sustainability or how would gaming influence sporting industry. So we have setting some input on the agenda, and then we see if there are industry partners really finding their synergies, and we should find steps to set up a research project, or we can directly go into industry-based project.
And do they tend to cooperate with each other, or is there some kind of, I have my own castle, I have my own realm, I don't talk to any other competitor?
That's why we say we will not, or this is all the coalition of the willing. So we do not want to expand as far as possible to get as many people as possible inside. But we have all the partners can know each other, and so they come and we create a good atmosphere, and we have also NDAs in the beginning, but if we come and reach a level where we can just discuss quite freely, and if everybody puts in their trust in their also shows up in the working session or the networking, then they can all contribute and also get benefits out of it.
And finally, what is your impression? Since when did this topic of sustainability increase in this sector as being something being broadly discussed, or let's say being discussed in a manner that something has to happen? What is your view on the, let's say, the progression of the last 10 to 20 years?
We had a intern in our company who is now vice mayor of Annecy, because he focused on sports and sustainability, and we said, well, this is really a hard way to go 15 years ago, and you will have to work hard to find a really foothold there. But he really found his way, and if you have a look at the outdoor industry, they, I think about for nearly 10 years, they're really into this area. But if you see on the big sports players, there's also, it's more greenwashing, or there's only the limit they do. so they're good that the EU regulations also on the green standards, and then there's also some pressure from really the politician and other players, also from the sportsmen themselves, from the athletes. They say, is this jacket somehow sustainable? So it's really slowly coming to also different parts of sporting and goods industry. But if you want to have the forerunners or the good examples, mostly you have to look to the outdoor industry.
So then if, let's say, a top athlete is the customer, they are listening. But what if, let's say, the general public as a customer would bring in the motion?
I think the bottom-up approach is quite loud at the moment. So if they're really coming to Globetrotter, to Patagonia, because they have also this sustainability aspect and really live it. It's not greenwashing. And companies like Adidas, they really have slowly think about their strategies, how they really fulfill their purposes. Otherwise, they will lose clients in the future. It's not only the athletes, the elite athletes. We're also working a lot with the elite athletes, and they have normally a quite difficult challenge because they have to travel all around the world, and this is by definition not good. But yeah, they're also trying to put in their weight and their energy to change something. So we have also elite athlete networks that's focusing on sustainability also.
Other questions from the audience? If that's not the case, thanks again, Martin. Let's stay a bit with sports, specifically cycling sports. And to this end, I would like to welcome Andreas Wiedmann to the stage. He represents company Textile, who is part of the Unternehmerverband Südtirol within the textile community there, and is representing their efforts here. And maybe this is a topic more or less in alignment with the things Professor Pham already told us. It's about recycling a fiber to gain a new fiber. So, Andreas, if you would start your presentation, and we are happy to see what your company already did with your cooperation partners.
Okay, thank you. Yeah. Hello, everyone. My name is Andreas, and I'm happy to be here. And I'm going to give you a real-life example of fiber-to-fiber recycling. We have heard a lot about fiber-to-fiber recycling or textile recycling from Professor Tung in the first presentation, and I'm going to show you an application in the polyester recycling. So let me start. First, I'm going to kick it off by giving some backgrounds about the companies involved in the project, showing you the project results, going through the process flow, how we actually obtain a new jersey from an old jersey. And the fourth point, I'm going to talk about the challenges. I think the main problem of the recycling are the challenges that we have, and I think that's also, let's say, a bit the bottleneck why I believe that recycling has still a big issue nowadays. And last, I'm going to discuss about future applications that we are already working on. Okay, so who are the companies involved? So actually the company I represent, Textile, is a small fish in the pot. So the big players is Radici Group. Radici is a multinational company with headquarters in Italy. And they are specializing in the production of chemical intermediates and especially in high-performance polymers and nylon. Let's say nylon is one of their main products they sell to textiles, but as well as also to automotive companies. The second company involved is Erema Group. They are specialized in the production of recycling machinery. So in thermomechanical machinery that allows you to obtain chips from polyester waste. And the last, it's us. So we have headquarters here in South Tyrol and manufacturing in Eastern Europe, Romania, as well as a small company in India and in Bangladesh, mainly for offices, but also for local production. So I'm going to show you now a video, okay, for you to understand how the process works, and then I'm going to provide more details in the slide to follow.
If you want to achieve what has never been done before, you need ambition. This is what brings you from what if to let's do it. So, the question is, can you fully recover polyester textile waste, such as from a bike jersey? To make this fiber-to-fiber process feasible, the R&D teams of 3 companies joined forces. SportsTex, who specialize in the production of sportswear, Radici Group, with their many years of experience in circular economy, and Pure Loop, a company specializing in man-made fiber recycling machines. Shimano was the first company to embrace this sustainability project when it branded the first jersey coming from this supply chain collaboration. The first step in this chain is the sorting of used garments at Erdotex. Thanks to their process-specific procedures, Erdotex makes it possible to recycle fibers, with the aiming of developing a real industrial process. What follows is shredding and extruding with machinery from Pure Loop, a company within the Irima Group. Before pelletizing, the IV level of the feed material is increased to the same level as virgin material. The next step is to produce yarn from the recycled pellets at Radici Group, where the R&D people are able to optimize the spinning process to obtain high-quality fibers that satisfy both technical and environmental specifications. The yarn is then knitted into fabric. The garment itself is then made and customized by SportsTex, which is part of the Tex Market Group. Once scaled up, this sustainable circular economy technology will make it possible to easily produce recycled polyester garments that, at the end of their life, can be recovered again. Thanks to this project, the partner companies proved the feasibility of circular economy with recycling projects that commoditize materials otherwise considered as waste, reducing the environmental impact of the textile sector.
You have seen now, you catch the main idea. What are the project results? Before I start with the results, I want to say that let's say in the press of textiles, the project has earned quite some success, so has been cited in over 50 newspapers, has been mentioned, this process, and it, at the end of the day, demonstrates the feasibility of fiber-to-fiber recycling for polyester. So the shirt that you have seen was 100% polyester. Everything is polyester. So basically the label at the back is polyester, the threads are polyester, as well as the fabric is polyester. So that's one of the limitations that you have, yes. And sorry. Okay, and what we have seen is that, sorry, yeah, maybe I speak like this. So an initial result was obtained using a mixed recovery techniques, dosing variable percentages of granules from recycling bottles together with polyester granules from recycling fabrics. So what does that mean? So at the beginning we have tried to obtain a jersey with 50% polyester fabric and 50% PET bottles, and we have seen it was working well. So in the lab, Radici has tried to increase the percentage of recycled polyester granules, and in a lab test they have achieved the first 30 kilogram of fiber with 100% polyester. I can share also some results. Now we are doing the first industrial test with around 2,000 kilogram of polyester, and luckily we have mixed a lot of different fabrics, 100% polyester, and we have seen that the lab results of the first test couldn't be reproduced on an industrial scale. So the fabric that we are producing right now, so the 2,000 kilograms, They are 50% polyester from recycled clothing and 50% from recycled PET bottles. So what does the process look like? So the process is composed of 5 steps. There are more steps, but these are the key steps. And so we, or let's say TextMarket, is controlling the first step, the 4th step, and the 5th step. And I'm going to explain now the details. So the first step is obviously the collection of textiles. So in the lab test and in the first industrial application, we have collected rests from cutting, okay, as well as also textile waste. So for example, pieces that are second quality that couldn't pass the quality control process, and we have asked also some customers to send us some of their garment that they still have on stock. The second process is we have collected all of these materials and send it to Erema, to Pure Loop, it's one of their brands, to Austria, where all of those textile waste is processed into chips. So small polyester chips that then can be sent to Radici Group. Radici Group has in its group a lot of different sub-companies. So the chips went from Austria to Switzerland, to Neufil, and then Neufil basically did the fiber, so the extrusion of the fibers. Those were then sent to Italy, where you really have then the fiber that can be used on an industrial basis. This fiber is then taken by us and knitted by one of our partners in Italy, circular knit. So from a circular knit, we obtain basically a grayish fabric roll, which is then dyed at the dyeing company. So you will say, okay, but why do you need to dye white fabric? Yes, you need to dye every fabric because in the dyeing process, you also give stability to the garment. Okay, and you can also treat it with some chemicals, for example, anti-odor and so on. So those are, let's say, applications that you give in the dyeing process. Okay, so that's basically the circle that the product is doing before we can obtain a new fabric. Okay, now I think this is the key slide. What are the challenges in this process? So we start here at the first step, is the collection of the waste. And as I said here, the main limitation is that the garment must be 100% polyester. And if you take a look at the garment, you will see that garments actually have a care label or a composition label. And these labels are many times made out of paper or made out of nylon or made out of other synthetic fibers. So you have to get rid of them first. You have then complex garments which have zippers. Okay, so there are zippers which are 100% polyester, but you need to make sure that the zippers are really 100% polyester. The next thing is also the labeling of the textiles. So in the industrial test that we have been doing now, we made sure that we only got 100% polyester, but I think that some of the fabrics, although they say they are 100% polyester, maybe there is 1% of other synthetic fibers in it, and then they make it incredibly difficult in the extruding phase of the fiber, because the fibers are breaking when you create the thread. And another challenge is where to collect it and who pays the cost of the transportation. So it's extremely costly, and also the shops or the collection points must be organized. No? So many brands would have to, let's say, collaborate together in order to make it feasible. The next step, which is critical, is the second step. So here I want to explain something that is not maybe obvious to everyone, is that the products that I've been discussing are sublimated items. So a sublimation, for sublimation, you always start with a white fabric, okay? Then you print the design on a piece of paper, and then you place the white fabric on the paper, okay? And you put it into a transfer press where the design is sublimated into the fiber of the fabric, okay? So the fabric itself is, now you see here, this is a little bit yellow, but the pure fabric, so say virgin polyester, is completely white, yes? But also on this test here, it's yellowish, but it's still okay. Yes, so the color is entering on the garment only on the surface. Yes, so the idea of the fiber-to-fiber recycling for sports goods is that at the end of the circle, you come up again with a white fabric. Okay, so that's one of the key points, and that's also why I said there is still progress to be made here in point 2 for the de-inking. So Erema, they have also another company that is specialized on de-inking, okay, which opens up the fiber structure of the polyester and tries to extract the color elements that are inside the fiber. So that's still something that they are doing already, but is relatively difficult, okay? And for sports garments, before we have heard, okay, consume less, but for sports garments, for a handball team, for example, it's important to have every year a new jersey because also the sponsors and the players, they change every year, so they need to have, let's say, new designs every year in order to also get some funds from their fundraisers from their sports. So that's basically the second problem. And the third problem is from Radici's side. So in order to create a new fiber, okay, you need to make sure that the viscosity of the polyester is at a very high level. Yes. So if you think about what is the ideal material in order to obtain a polyester fabric, the ideal material is a PET bottle. The PET bottle is super good to create a recycled fabric out of it because it has a very high level of viscosity. If you start from a cycling jersey or a running jersey or whatever, the level of viscosity is already much lower. And when you, in the extruding phase, so when you create the fiber, you have a lot of breakages inside the fiber, and that makes it difficult. So they're still working on new additives to make that process better, to improve it. And last but not least, I think the main problem at the moment why circular economy in textiles is still very difficult are the labor costs. We work in Eastern Europe, mainly in Romania, and just as a comparison, we all think Romania is, let's say, low salary or low income country. Yes, compared to Italy, yes, but on a global level, compared to India, Bangladesh, or Vietnam, we are talking about labor costs that are 8 times as high as in other countries, because in the other countries the cost is lower and also the minutes worked per week are much higher. So in India, for example, you have a 6-day work week, and in Romania you have a normal 40 days work week. So that's the main problem is that it's too expensive to produce in Europe, and that also the customers are not willing to pay so much more for European-made garments. And what is the solution for this? Obviously, to try to automatize as much as possible production processes, but in the textile industry has been always very difficult, and for textile machinery, the progress or the automating progress during the last 50 years was almost zero, sincerely speaking. Why? I've talked to, for example, KUKA, and they said that being the labor cost in other developing countries so low, it's not the interest of the big players, Nike and Adidas, to invest in these technologies, because any robot would already be or cost a multiple of what the actual product cost would be. So these are, let's say, from my point of view, the 4 main challenges. I continue. Obviously, what are the applications? So the applications, so we are already now doing the first event in Holland with a company where the running t-shirts have been collected and sent back to us. And the next running t-shirts for the next event will be made out of recycled polyester t-shirts that we are reprocessing right now. Another advantage or direct application is that you can reduce the cutting waste in the cutting room to 0 if you're talking about polyester. So when you imagine you're cutting a soccer t-shirt, okay, between the different cut pieces, you always have some rest or some waste. And at the moment we are taking off this waste and recycling it. So from an average of 20% waste in polyester, we are now able to reduce it to 0% waste because we are recycling all of it. So that's a major achievement. And yeah, one other future application is maybe we are not able to have a fiber-to-fiber soccer t-shirt in the future or in the near future, but at least we can start collecting this waste, this waste material, and use it maybe for other industries. So we can, they can produce, let's say, lower viscosity polyester for parts in sports goods industries or also in the automotive industry. So these are, let's say, future applications that we can think of. Yeah. So this was the jersey from the video. So it's really out of, so it's possible, as we have seen before. And you see here, this is the yarn. So it's a little bit, it's not white, but it's a little bit yellowish, but that's fine. Okay, yeah, thank you very much. If you have some questions, I'm happy to answer.
Thank you very much, Andreas. Questions from the audience? Yeah.
Is the yarn done from staple fiber or it is a continuous filament?
This is, no, it's continuous, so you can see it. It's continuous filament.
Continuous filament,
Yes.
great, okay. And do you really need pure white to get the sublimation, or do you think in future it could be acceptable also? Because I think you have to take off the color in any way to reach even a yellowish or a grayish white.
So here in sublimation, for example, in sublimation, when you make a one-off production, it doesn't need to be pure white. But then the problem comes when you now, for example, imagine you have a collection order of 500 pieces for the next season, and then you have a reorder of 50 pieces, right? If you have a reorder and you want that the reorder has the exact same color as the first order, then it's a problem, because the next roll of fabric might not be this white, but might be a little bit whiter or a little bit bluer, and then the color is not the same. So you have in the shop those running shirts hanging, no, and one will be, let's say, yellow, and the other one yellow with a little bit of blue in it. So that's the main concern.
Yeah, okay. In that case, you would need to adjust the transfer paper.
In that case, you would need to adjust the transfer paper, but it's
so easy.
difficult to obtain. Yes.
Thank you.
Let's stay at the dyeing. So your cooperation partner has the, let's say, the task to develop a dyeing process, extracting most of all the colorifying agents, and on the other hand, to have a solvent which later on doesn't pollute the environment, right? So that's a quite large job with large responsibilities. So how are they coping with that?
Yeah, maybe here I think if I go back to that slide, so one is in one production step is, I even go back one step further. So here, one of the challenges is here, yes, about the dyeing. So in the phase where you produce from the waste the chip, yes, in this phase you can heat. So they're already doing that now. You heat up the polyester material, and when you bring it to a temperature of around 200 degrees, yes, the polyester fiber opens up, and the color is basically vaping out, so to say. It's a desublimation process, and you get the color out, right? And that's one part of the story, yes. And then in the second part here where the fabric, you can dye the fabric or you can dye the yarn. In this case, the fabric is dyed. They're trying to dye it white, so to say. Yeah. And those, I have to say, that is those processes is done here in Italy, and the regulations in order to make dyeing to be able to run a dyeing factory in Italy, they are very strict. So they are not allowed to use dangerous chemicals, and all the wastewater that they have needs to be processed by certified companies. So the chemicals that they are using, they are really strictly controlled. What is interesting to say is, if your objective is to obtain a dyed material, so if you now say, I don't want to print the jersey at the end of the life cycle, but I just want to come out with a blue shirt, that would be relatively easy, because you start from a sublimated item that is only on the surface printed, and the rest of the jersey is still white. Okay, and then you can dye it to a darker color. So you can always go darker, and that would be relatively easy in the production process. So you can start from a soccer jersey or cycling jersey and make out of that a blue dyed soccer jersey for training. So that would be already relatively easy possible. Yeah.
Questions from the audience?
So in the desublimation process, the desublimation process is again here, no, on this. So you have the color is a process. It's sublimation and desublimation. No, it's coming out as vapor. Okay, and then it's collected in a container as a powder. Yes, as a powder. But that's you cannot reuse it. No, you cannot reuse it because. Yes, I don't think so, because the color is CMYK, so cyan, yellow, magenta, and black, and you would have to separate it into the 4 components. And when you desublimate it, it's just every color is mixed. It's like if you I don't know if you mix the colors and then you have it's like you have these watercolors, right? Yes, and when you put all the watercolors in one container, that's the result that you have, right? So you cannot use it anymore, correct? Yeah, that will be the result. Yeah.
Okay, if there are no questions, thanks a lot. And we continue with the next talk. Christine, since you asked so many questions, why don't you join us on the stage? And yeah, it's your turn. Christine Ladstätter and Valentine Treu will now give us a completely different perspective on sustainability. They are trying to use natural fibers to produce either garments or sporting good parts. And therefore, let's welcome those two. On the one hand, Christine Ladstätter representing Oberalp-Saleva here from South Tyrol, and on the other hand, Valentine Treu representing Standortagentur Tirol in one of the bigger projects they are going to talk about. So, please tell us a little bit more about your approaches regarding alpine hemp and other natural ways of sustainability.
Hello, also from our side. As Peter introduced us already, I'm Christine, and I'm here with Valentine. We are the hippies of the situation, I think. So we proposed this topic because beside polyamides and polyester, which is certainly all are the main fibers of our Oberalp sectors, also in sportswear and sports business, these are the main contents, and I'm really excited that textile to textile recycling into circularity is doing steps forward. We would like to share the alpine hemp Hanf project with you, because we are working on this topic already several years, and we learned that renewable resources are extremely important also for us, and the learning field is extremely interesting. We in Saleva started to look into this because we started to work with local wool, with the Tyrol wool project, and we learned that knowing where the materials are coming from and getting them very close to us is also very interesting, and also for the, let's say, the people working in the sector. And so we came to the, or we decided internally, let's look into this topic more, and let's find maybe another fiber which could be, I say could be because it's not yet there, or we are not yet there, but Valentina has done some more work in this direction, to have a fiber which maybe in future can go closer to us. So we looked into cellulosic fiber as an alternative to Tyrol wool, as an alternative also to synthetics with their, because they have problematics. And we found hemp, which is very, very, very old fiber and has been with humankind, let's say, thousands of years. Also in our territory. Maybe later you can see some example on our table behind. Here you see an old fabric veil which has been done in one of our valleys. Personally, I find this kind of textiles which have been handmade in our territory super interesting because let's say I have a personal connection to it because it was my first approach to textiles. And people actually realize them locally for their needs. In Pustertal, in the Puster Valley, linen has been really famous at the time, but people needed also hemp, because hemp is the strongest fiber, natural fiber in its natural stage, and it allowed humankind to do a lot of revolutions, let's say. For alpinism and mountaineering, the hemp rope were essential. But also for our farmers, the working tools as ropes in foresting and farming has been super important. And when we looked into it, we said, this is an extremely exciting fiber, and we would like to find out if we would be able to do we called it Werkstoff, to do a fabric which would allow us to build mountaineering trousers, climbing trousers out of this fiber, and to make it also contemporary and understandable from our customers. But because what we are doing is polyamide 6 and 6 with elastane, polyester fleeces, and this is what we have done in the last 40 years. And to understand natural fibers for active activities, it's not so easy, but we have, as humans, we have also a relation to it, because the fabrics have a different appeal. They are full matte, they have a certain porosity, and so we went into this development and into the studies. You see here on the different stages. So we have the tradition at one hand, this relation to where we are coming from in alpine or in mountain life. We have the fabric studies, we have our sport, our climbing activity. And so we built fabrics, we tested them, and we learned that this fiber actually has some really interesting properties, and especially if we talk about performance, so next to the skin performance, so we have a certain hydroscopicity where the fiber absorbs and releases. It feels comfortable to the skin. It has a good thermoregulation. So our long field testing showed us that it could work, but what we discovered, and what is even more important to the project and to the concept is that the crop, this industrial hemp, is an extremely interesting, and let's say for the challenges we are facing today in terms of climate emergencies, limited resources, etc., it might be in part a problem solver for future products. This I skip. and so to understand the crop better, we decided that we wanted to see it if everything what we learned and we read and we heard, that it grows so quickly, that it doesn't need water, that it enhances the soil vitality, that you have a lot of biodiversity around it, is true. And we have this luck, we have this Saleva garden at the headquarters, and so we just decided to have a small hemp field over some seasons. And we observed it, and during this journey we met Valentine, because we have seen that it's super important to collaborate, because it's not just a question of fiber, but it's a question of collaboration from agriculture to different products. And so we started this collaboration, and we have seen that there is a lot of potential in it. So I hand it over now, and Valentina will tell you more.
We have already seen the end of this project. When we met, Christina and me, I met them as a company. I have a very, very small single woman person company, Toy Composite. And we were here at Saleva in Bozen, and we talked about quite a lot of people. It was an event also organized by Standortagentur Tirol. We talked about that we need more products in hemp so that we get more famous with this natural stuff. And I said, oh, I did quite a lot of things in carbon and in glass fiber tubes, and I switched to natural fiber, and I said, yeah, I will be able to do for you, Saleva, a tracking pole in hemp, easy. And it was not so easy then in the end, because a lot of material in flax is available, but not in hemp. And so this is 15 years old, where I did these tubes in flax. And they then said, no, we needed it hemp. We decided to go on hemp, not on flax. Okay, no, hemp. And then we made some trials. I said, but it works. No, we want to have it in hemp. Then we really needed to go into braided hoses in hemp yarn, where Christine was organizing this hemp yarn, because the hemp yarn, the 100% hemp wet spun, is not available so easy. And it was then not the way, because it was not stiff enough in the end. It's maybe the question of the angles of the braided hose, but also because then I realized the fiber directly from the stock is extremely strong, but the fiber then processed to the yarn is only half the performance, for example, on the E module. So we really had to change, and we went back on the Saleva garden, and we took our fibers directly, and then we went on, and I realized, there are quite a lot of colors depending on the harvest time and then on the retting. And I went on with the project. I had the green and the gray and the really dark ones. And I really nerded into this topic as a company. I nerded into this topic. What are the parameters for the performance of the fiber then in the composite? This is a very interesting topic. I'm still nerding in it at the university at the moment. So we did the test of 64 different fiber guys from the alpine space. And yeah, in the end then, we also did the colleg, we did the ski. It's a tracking pole, it's not an alpine skiing pole, but the picture is nice. And it works also as an alpine pole. And then the right people had to meet, because we are a little bit the ghostwriter. So I met the Data F and Leki, and then we went on with the project as a product. And they were really cool, the Lekis. They had this quite logo, then the future belongs to the hippie. So we did the sticks, and they did all the rest. And so we had this nice product. Okay, but then the standard Tyrol is nearly as small as South Tyrol, so they knew me and they realized that I'm nerding into this topic of the fiber and how to get the fiber and how to get the fiber in the alpine space from the farmer. And then they asked me, wouldn't you like maybe to make the whole circle of this plant for our space, for our habitat? Because we know that the plant is good, is very good for us, would be also grow here very nicely. And we know that there are a lot of materials you could do this circle. And I said, okay, that's a nice opportunity, let's do it. And I knew that I have some very good network partner. And so we started with this project. It's 2 years ago. And yeah, if we have a look, we always have to start here in the alpine space because we are not an agro region. We are not. We are too hilly. With the food, first of all, we always have to harvest the food. And then we can take the rest of the plant as a agri-waste and make out products from it. And it goes until the end of life. And that's with the grown stuff always a lot easier, especially ending then in the plant coal, which is a very interesting topic at the moment. Okay, so I got the funding at Standardagentur Tirol, because Standardagentur Tirol, we don't have money, we need other fundings. And it was a very nice funding from the AG Alp, and it was good for me because so the connection to South Tirol could grow. And we had 10 alpine regions from 4 countries. So very interesting zone for this hemp project. And it grows. It seems, this is in Graubünden in Switzerland. It grows very well, quite high. And we realized that it's a special situation to have the product here in the alpine space. We need working groups. Working groups for, first working group is food and harvest. Second working group, in a way, is the sheaf. So you can see it then in the end. The inner thing on the stalk is a sheaf. And with the sheaf you can do very good building material. And then it's our topic, it's our group, the fiber working group, and then the biomass group. We also count the cellulose to the biomass group. So, and all together we tried to make as many products and chains with a, let's say, local connection, regional local connection. And yeah, at the moment we are on 64 projects. We have the 64 projects in a flip book at our homepage. And it starts always with the food and it ends with end of life. We are traveling around, but now let's go very fast through this possible chain. We start with the leaves, with the for tea, for example, and especially with the nut. From the nut you can do oil and protein, but for me the only possibility to bring it further was to talk with the brands, Agrarmarketing Tirol we have, and Bier vom Berg, and to start with small projects with this SAM, very nice, and also with the chocolate. And because we need the food for bringing forward the industrial products in our region. And then I always say the very clever ones don't even try to separate the fiber from the sheaf. They just make the hemp wood, they just press it. This is pressed with a bioresin. And yeah, we have some sample over there. It's a Bavarian, quite cool guy, also a very small company. And then if you not only try, but you also got it to separate the sheaf from the fiber, then you can do the building material. Very nice company here in South Tyrol in Finchgau doing the bricks very, very good. Also with the Kohli sheaves. And then after the sheaves you have the fiber. You have the fiber in a lot of different qualities. It depends where it grew and where it comes and where it was processed. The finest one still comes from China. They are the best in doing the textile fiber. Compliments. So we start with a very rough one. The very rough one, as I said, was the best solution for the poles. And then it was also, the Saleva had their garden, and then the Lakis, they also wanted to have their garden. So they really tried to find a farmer in Schwäbische Alb, and he did the hemp, and it's not so easy to do the hemp. And they did it now the second time, and we had to harvest, and it's not so easy. We have also harvest machines in our topic. And then we did some regional fiber, where we really would be able to do some felt. This is East Tyrolean fiber in combination with mountain sheep wool. And then we did a 100% Tyrol beanie, very hard work. Doing a textile in 100% region, it's not so easy. So we had a nice testimonial. Manu de Lago, he wanted to have his beanie from the colors with like this. Yeah, we started. We did it, but it was a lot of work, and we needed companies being quite experimental, doing our mixes in their machines. The old machines were the best ones in doing the trials, these old wool machines. And yeah, but now we found, as you saw, Lombardy is also part of the AG Alp. We found a very nice project. It's Prototipo Studio di Lampoon from Milan, and they are doing prototypes for the Filiera Italiana. So they more or less the same than our 100% Tyrol try. And now it's Christine's turn again, because we switch a little bit.
Okay. Yeah, this is Lampoon. This is a very modern communication agency, and we have discovered about 3 years ago that they are working in the same moment on a similar project, investigating what's possible with this hemp fiber. Their final goal was to do this 100% made in Italy supply chain. They started, same as we, but we are still there doing textiles in China, because we work for another customer. At the moment, they are building up a local Italian supply chain, doing a controlled water wetting and spinning the material with a small spinnery, very capable spinnery. They have done this mixed wool. So here we find again the project we have done with hemp and Tyrol wool, which Valentina has done with hemp and Tyrolean wool sheep. And realizing a very, let's say, technical structure, which comes actually from the towels, because it's super airy and super drying, the waffle structure. In our conversations, we said we would like to collaborate to show what it's possible doing as in prototyping. They did the fabric, we did the style, just to show that local materials are possible, even if they are super exclusive, because these are designer pieces which are then sold in Via della Spiga in Milano. But in any case, it's an example, and we think it's important to show samples and to show feasibility, because otherwise it's just on papers and not a real product. This is a sample you find also on the table. We have put and behind the room. Is this going? So I go back to Valentina then.
Okay, with our partner DTF, we also did a PLA hemp composite. It's a yarn, it's a filament. I'm not the textile expert, so I. And they are making this kind of semi-finished for sports. And if you go further, if you make it thinner and thinner, then you come to a level. The Belgium and the French guys are very good in it. It looks like this. And
okay. Yeah, and this is another showcase of our collection, is the hemp jeans, which is at the moment the only product beside, but the poles are not on the market, it's just a manufact. The only product we have realized in the collection with European hemp, this is Belgium hemp blend with organic cotton, and the jeans was realized in Milano by Blue Collars, which is a jeans specialist doing very clean working ways to show that also a local material, or let's say a nearer material, is possible, but in terms of mountain sports is on the limit, because this is a heavyweight jeans, no elastane, so it must be appreciated for its originality in sense of jeans material, and not for its lightness and performance. Performance, it's not so bad because it's thermoregulating and super comfortable next to the skin.
And let's go back to the composites. You can align the fiber as a UD laid fiber, and we did this key with a small manufacturer in Innsbruck. It was quite hard to do a BX. Meanwhile, they have a BX. And it works. We have a movie with Simon riding on these keys. We have the 50% hemp ski with 50% glass fiber, but we also have the 100% hemp ski. And it's a bigger project with another ski manufacturer in the moment. And we really hope that we can substitute some glass fiber with the hemp fiber. And then the fiber gets thinner and thinner. And then you can go into the hemp padding. So substitute the polyester filling with hemp. But that's the expertise of Christine again.
This is actually the very first trial we have done with European hemp. It's still at the field testing and prototype stage, because we have our proprietary insulation with Tirol wool responsive. So we have not introduced yet a new content version. But as you imagine, insulation, it's easier than yarns and fabrics. So we created a blended insulation with German hemp and lyocell hemp, coming out from the prototyping charge from Lansing, because they also worked on cellulosic matter for the lyocell technology. Only 25% of hemp content, not 100% for the lyocell fiber. We made out this isolation jacket, which has also hemp ripstop inserts, and tested it now over more than 2 years' time. And people actually testing it in mountaineering, so it has been also on the Marmolada, is wondering, because they don't know this kind of content, and they are really wondering that it works. It can be compared, especially in terms of comfort, to polyester insulations, which is the mainly content used in this sense. The Tyrolean brand Sina has taken up also this product idea at the very beginning, and is offering insulated gloves with in the blend hemp and wool, which actually is also a very excellent fiber combination, because they collaborate quite well. So here a picture of our first launch of the alpine hemp fabric and development. It was trying to climb, so a fabric which we developed in terms of weight and content, that it could be used for climbing. We wanted to achieve a fabric which was not heavier than 200 grams, should be slightly stretchy. We started with pure hemp fabric, which you can see also on the table, but which was far away from what the sports customer understand in terms of feel and weight. And so we decided that we needed to go with a blend. At that time, fortunately, textile to textile polyester was not available yet. We used PET recycled polyester in combination. We got a good result. We decided to test it. We tested it over more than 6 months with intern people because we needed to learn internally first what hemp fiber really stands for. And this was a very interesting field test because people didn't want to give back the trousers afterwards. The other learning we found is that there was no need to change after the activity because hemp is naturally antibacterial. It does not gather the smell of the sweat, and it's so comfortable to the skin that they simply, it's like a blended. We speak a lot today about fluid situations from sports into daily wear, etc. Hemp fabrics are very suitable for this. So this was the launch for the project, our ripstop. Then I go on. We have now several fabrics. One of the newer ones is the hemp stretch for our alpine trekking. It will be on the market for next season. Here the aim was to substitute again one of our Dura stretches based on polyamides, filaments and elastane. We wanted to have a cleaner aesthetic, lightweight and more stretch that we could achieve with the elastane content, which was very small. So we used the bio-based polyester fiber from Biocoration, Sorona. This is coming partially, it's not 100%, from industrial starch maize. In terms of sustainability, here we would need to open another topic because it's not, let's say, a real sustainable fiber. It's renewable, but in agriculture it has let's say, its dark sides because you need energy, a lot of energy. You need pesticides, and it's let's say an intense crop. But there is a balance program which is called Truterra in order that agriculture, and this is an important part because agriculture needs to be sustainable, let's say balanced in terms of land use and impact. So the Sorona fiber or filament allowed us, because it's naturally elastic, it has this crimp, which allows us to create a mechanical stretch and a very clean aesthetic. So in the warp, we used 100% hemp yarns, and in the weft, the Sorona yarn, and we achieved this lightweight. It's 180 grams. Very comfortable next to the skin. Fabric which we propose for the modern trekker, where you have this convertible and multifaceted used items. And last but not least is the midsole, always for the trekking, upcoming trekking range, where we use post-industrial, which we heard before also, post-industrial cutoffs, which we have in the textile industry in every stage, which are worked into the EVA material for the midsoles of our trekking shoes. It's a small part, 10%, but it's, on the other hand, at least 10%, achieving the same performance we needed, because otherwise we could have put more. So here, this shoe, which we will launch, and we have the sample on the back side. And back to Valentina.
Maybe if I may interrupt, we are still a bit over time. How many slides?
I hurry in 2 minutes.
Yeah,
okay?
Because coffee is cold.
Okay, so we are still finding solution for the whole biomass, and this is very important for the agriculture here. We have a partner in Germany. He makes kind of paper, very strong paper for leather substitution. Tack, tack, tack. Thumb cinema. And then we have the cellulose situation that we think that you can do the cellulose on that maybe then from the whole biomass. And this is also a Saliva project with a cellulose base. Candiani with Lansing is doing a similar project. And then we have the last project before the paper, that it's a technical project. It's a filament done from the ETF, also from the whole biomass together with French partners. And yeah, that's the last picture now. We end up with a paper and saliva on the paper, and yeah, that's it.
Thank you very much. As Christine and Valentine said, there is an exhibition at the back of the room. So during coffee break, which I would like now to cordially invite you to participate, grab your coffee outside, come in, look at the exhibition, get into talking, and we'll continue our talks at 4:20. Okay? See you then. So in the second half of our talks today, we turn our looks to the university. We started with the university, and now we close up the whole event with another universitarian perspective. Our first speaker from University Bolzano today will be Martina Aurora Costa Angeli. She did her postdoc here at the University of Bolzano, where she also received her PhD in 2020, on the topic of inkjet printing of deformable strain sensors. So I think now we are entering in the realm of wearables. And Martina, please join us on the stage. Let us welcome her and let's hear what she's going to talk about today.
Okay, thank you. I don't know if you can hear me. Yes. Oh, can this one? Okay. Okay, thanks. Thank you very much for the invitation and thanks to be here. I feel a bit out of the topic, not out, but in the border, in the edge of the topic, because as you can see from the slide, I'm a researcher at the University of Bolzano, working in the group of the Sensing Technology Labs. So what we do is to develop new kind of sensors, not the standard sensor based on silicon wafers, so rigid, the sensor that we are used to use or interact indirectly, but develop sensors that are based on flexible substrates, and in this case, sensors on wearables. For us, wearables, so is a substrate, is something that you use to carry on, to deploy on it active components and conductive materials to sense several aspects, and today I'm going to focus on the wearables materials, wearables device. Why wearables? Because wearables allows us to gain a lot of information for our physiological status from different perspectives, from the clinical perspective, so how we behave, and from also the application in sports. Nowadays, we know that also in the market we can find several devices that allows us to gather several information, like the breathing rate, like the heart rate, like the pulsation, and so on. And in our activity today, I'm going to present two different projects, that one of which we just finished, and the other one that we are carrying on nowadays on the development of sensors for monitoring breathing rate and impedance analysis. Shall we start with the first examples that is related to the development of printed and textile-based wearable electrode for impedance plethysmographies. First of all, shall we say what is an electrode? Electrode is a conductive materials pad, and probably we are all experience what is electrode when we do ECG analysis that is attached to our skin and allows us to record some bioelectrical signals. For instance, the heart rate. Electrodes are usually made of metallic materials like this one, and are attached to a glue gel to our bodies, and this allows to record the electrical signals that are produced by our bodies. One disadvantages of the use of this electrode is that this electrode cannot be used for long-term wearability because the use of the gel induces an irritation of the skin, and they are bulky. They cannot be used outside the clinical environment. One possible replacement of the electrode is the development of textile-based electrode. Electrode can get integrated into the textile by using a specific conductive materials or by using conductive textiles as well, that allows us to fulfill some requirements that are related to the ability to be used for a longer term compared to the traditional electrode, the possibility to allow the skin to breathe, and also the possibility to use this kind of electrode for different kind of application. And particularly in one of our projects, we wanted to develop electrode in order to monitor the characteristics of our peripheral circular systems by using impedance plethysmography. Shall we back to a bit more physiological and medical perspective of the problem? Impedance plethysmography is a non-invasive technique because you need an electrode attached to your body that allows to measure the peripheral blood pulse wave. And particularly the velocity of the blood that cross your peripheral system. The velocity of the body, and so the change of the blood volume that pass through the arm or to the foot of our bodies, is an indicator of the possible occurrence of deep vein thrombosis, and so aging of our peripheral systems. This is a method used in clinic by using an optical technique and a bit invasive method. The aim of our project is to develop wearable electrodes that allows to monitor, to evaluate these signals in order to predict the possible occurrence of pathology related to the thrombosis. To do that, we are collaborating with the Oslo University Hospital with a PhD project that is done by Camillo, that is here with us. Our collaborators in the Oslo University Hospital, Christian Tronstad, started working on this project by developing a flexible electrode strap for impedance plethysmography used on the dorsalis pedis arteries. On our foot, there is the biggest arteries that goes from the ankle to the thumb, and by measuring the impedance, so the electric impedance spectroscopy of the blood that pass through the foot, we are able to detect the signals that you can see here in this image, and extract some parameters that can be evaluated by the physician. One thing is that one advantage of using these systems is that this system can be weared somehow, even if it's still rigid and uncomfortable by the patient. And so the test can be done, because if you think about the electrode that I showed you before, that electrode is too big to be placed. We need at least 4 or 6 electrodes on our feet. The problem that the researchers faced is that the system is working, but the patient suffer from irritation and problems on the wearability. And so they didn't want, they rejected the use of the system. Our aim is so to develop wearable similar devices like a garment, a socks, that allows us to fulfill the problems that the patient faced. And how to do it? We decided to use a technique that is called screen printing, that is widely used in the textile industries, but instead of printing a dye, we print conductive materials. These conductive materials allows us to fabricate an electrode that can then integrated into the textile. The fabrication process is quite simple, as you can see from the slide. We screen print stretchable conductive material on top that could be carbon or silver, on top of a thermoplastic polyurethane substrate. Afterwards, we encapsulate the eye area that has not to be in contact with the skin, and this allows to prevent also that the sweat interact with our conductive lines. Then we shape the sensors only in the area that are conductive, and then we laminate these conductive structures on top of the textile. Here you see an example of the same structures, the same fabrication process that I just explained to you, in which you see 3 different conductive lines that were laminated on top of a sports wearable t-shirt. By using the technique, we started working on the development of the same flexible devices that you have seen before, but integrated into the textile. The first problem that we faced, and that Camillo well solved, was how to connect this flexible system to the readout electronics. Usually this is made by bulky cables that are called crocodiles, and you see an example here. What we did is to use the stamp, that is something that we are currently normally using in the wearing, and this allows us to connect the electrode of our system then with the portable readout system that we will have in the future of the project. The interesting aspect that I want to show, and this is why I brought here this topic, is that the technique that we used allows us to realize a fabrication technique in perspective of electronic device that is compatible with the textile production, because it's a technique that in a different way is already present inside the textile world field. The other aspect is that we started developing of a wearable and comfortable devices that can be embedded into the textile. As you started, this is still a work in progress, so I hope to see you next year to give you more feedback. The second example that I want to show you today is the development of similar devices. So by using the same fabrication method, but to develop a wearable strain sensor for measuring the breathing, and particularly the breathing rate. This project, this work, was a work in collaboration founded by the European Union, in collaboration with Microdata and Textmarket as well. Why we wanted to develop breathing rate sensors? Because breathing rate in sports application, for instance, especially in cycling, is an indicator of the muscle exertion. And so having a sensor that is integrated into the textile allows us to predict the onset of the fatigue and prevent so the possible occurrence of injuries. Obviously, to develop a sensor, so we need a wearable sensor, we need to fulfill certain requirements, and so it has to be compatible, again, with the smart textile industries, has to be weared by the cyclists without the feelings of wearing a device that is measuring your physiological status. And you see from this image which is the gold standards. Nowadays, what is done in order to measuring the breathing rate is to use a mask that allows to measure the flow that goes in and out from your mouth. Obviously, is a system really accurate, can give you the real breathing rate of the cyclist, but it's quite cumbersome and cannot be used on field. For this reason, in collaboration with the partner of this project, we started developing more comfortable devices based on smart textile. The idea was to develop sensors based on a band or directly integrated into the T-shirt. You can see the T-shirt there on the tables, characterized by a strain sensors. Why a strain sensor? Because when we are breathing, we are increasing and decreasing cyclically the circumference and the diameter of our chest. This means that our sensor is repeatedly stretched and release the stretching during the breathing. Particularly the deformation of our circular line of the breast is between 4 and 10% of deformation. It depends by subject to subject. Women has a smaller deformation, elongation compared, for instance, to men. With the same technique and the same approach that we are currently using to develop the bioimpedance electrode, we fabricated these sensors. This one. Characterized by a conductive structures based on carbon materials. The first step was to optimize these structures, and that was performed by performing tests, and particularly electromechanical tests at laboratory scales. I don't know if I'm able to turn on the videos. As you can see in these videos, we are stretching cyclically at the same velocity that we use for a normal breathing in this video, but we tested also by increasing the velocity because we know during activity the breathing rate increases, and so the velocity of testing increases by applying a total deformation of 10%. Test market gave us a different kind of textile to use as a substrate. And so the first aim was which is the best textile to be used in this application. Best textile, what it means, has related to 3 different aspects. First of all, the wearability. We know that the sensors has to be in contact, or at least the T-shirt on which the sensor is deployed on top has to be in conformal contact with the skin. And so among the different textiles that we received, we selected the textile that has a higher concentration of elastan and was more fitting the figure of the athlete that we used as first pilot studies. The other 2 parameters were related to the characteristics of the sensor itself. As you can see here in this slide, you see the variation of the resistance. That is the output of our sensors during time. Meanwhile, the sensor was cyclically stretched and released. A magnification of the output is presented here. Here you see the example of 2 different materials, Asteria Presente and Chrono, that are the commercial name of these materials. And if Asteria Chrono is characterized characterized by an higher amplitude. This means that the sensor responds better to the stretching compared to the Asteria pesante. You can see that over time the stability of the sensors change, and particularly there is a drift. It means that if I'm applying the same input, I have an increase over type of the output. And this we thought was related to how the chrono materials is structures and the different materials compared to the textile material, the Asteria pesante materials. So even if the amplitude of the signals was better for the green-based textile compared to the red one, we decided that for us it was more important to have a stable devices over time, because we know that we have to use this device to measure the briefing rate for a long period of time. After defining the final materials and design of our sensors, we went to Promotus, and in collaboration with the University of Verona, we set up our first pilot studies. As you can see here, the first test was done not on a t-shirt, but deploying, so laminating two different sensors under the axillae of the subject by using a strap. This helped us to better control the condition of working. And as you can see from the results, you see the variation, how it changed the resistance over time. Meanwhile, our subject is performing three different tasks: normal briefing, cycling, and recovery. Also, from a qualitative analysis, you can see how the sensor performs better during the physical activity. What it means perform better? I have a really higher amplitude of the response. This data is still quite a lot noisy, but in the post-processing data we can clean this data, and the frequency of the briefing design is increasing during the cycling activity. By post-processing the data, we extracted the briefing rate in terms of breaths per minute, and as you can see, the briefing rate starts with a normal briefing rate 16 breaths per minute, by increasing during the activity and by then decreasing after the stabilization. What is missing in the example that I'm presenting is that up to now we developed this sensor on a textile band. What we want to do is now to integrate the sensor into the t-shirt, how it is presented here. One of the limitations is that the sensor should be sensitive only to the deformation that is radial along our breast, and has not to be sensitive to the movement that is done to the body in the other direction. What we want to do is to try to redesign, improve the design and engineerize the textile area around the sensors in order to improve these characteristics. I want, first of all, to thank all the people that are involved in our research on the wearable sensor, and particularly all the people that collaborate and the partners in the project, in the two projects that I just present to you. And I want to thank all the people that is part of the Sensing Technology Lab that, as presented before, is a laboratories of the Faculty of Engineering held by Professor Lulli and Professor Petti. Thank you very much for attention, and feel free to ask questions, to answer to your questions.
Thanks, Martina.
Thank you.
Questions from the audience? We have time for one or two. Yeah, you know, that's the big thing with all the textile topics. You can bring lots of aspects into it, and I think this jump to other types of technologies is quite interesting to also go into this direction. So, besides cycling, is there anything you are also developing those types of sensors for?
we started on cycling, so the idea initially of the project was working both on cycling and running. We started for cycling because of the problem of the movement up and down of the body that it can induce a lot of noise on the signals. Meanwhile, during cycling, the body, the upper part of the body is a bit more fixed. The idea now is to try to improve the signal-to-noise ratio, this is called, of the output of our sensors in order then to deploy the sensor not only for this application but the other application that was related to running, for instance.
And the first example you've shown to us is for, let's say, general hospital use, or is it more intended for geriatrics?
The first is for general hospital use. So in hospital, they used a technique that is called photoplethysmography that is based on optics. Maybe you have heard about something similar during COVID time to measure the pulsation. It's the same principles. But if you think about the device, it's quite big. It's a cuff that you put on top of the fingers. So you cannot use it on the feet. So this is why we are trying to solve a problem that comes from the physician. I want to try to monitor that signals, and we have not the technology to do it. And there is also a bit of hostility from the normal people to try something that is new and is not comfortable. And so if it's not then used, there is not the reason to have it.
It's always the fear of the unknown, right?
Yes, exactly.
Okay. Thank you very much.
Thank you.
Ah, there is one question. I don't want to spare that.
So, yes, sorry. You showed us the period of the screen printing process, right?
Yes.
Which materials do you use for that?
So for the first example, we used silver-based materials. Silver is biocompatible and has a higher conductivity. In the second case, we used carbon-based materials because as a strain sensor, we need a resistance of some kilo ohm, and carbon has also cheaper compared to silver. It's a paste that has characterized by the composite of flask, microflask of conductive materials, carbon or silver, in a matrix and a polymeric matrix.
Okay, and so they are made with a solvent, right?
There is a solvent, yes.
Which solvent is it?
It depends on the paste. The solvent is used to give I'm going to technical information, I don't know, to give a specific rheology. So it depends on the concentration of the materials that you need. They usually are organic solvents, like for instance, isopropyl alcohol is a simple solvent, but it's a composite. So you have polymers plus a filler of metals or carbon. So we cannot call it really solvent.
Okay, so if it's not water, the solvent, could you wash it? Could you wash it later or not?
So the process is you have a paste. The paste looks like a Nutella. So when I teach this to my students, I say it's like you have a Nutella, but it's a conductive Nutella. And I don't know, you have your Nutella that is conductive, and you put a mask on top of your textile, and through a press, you push the Nutella through the mask. And so only the design that you want to have on the textile passes through. And this Nutella is based, there is Nutella and nuts inside. So when then you bake Nutella, it becomes a bit crunchy, it becomes solid, and the nuts are inside. The nuts is your conductive filler, and Nutella is your polymer. So it's not a solvent, it's a polymer that stays there and gives stability to the system. I don't know if I understood with nuts and Nutella.
Okay, that's good.
You can wash it, yes. I tried at my place. I went to my washing machine and I washed it 3 times. You don't destroy it, and this was the first release that you can wash and reuse it. It degrades a bit the performance after the 3rd washing of the system. So it's still in process.
Thanks again.
You're welcome.
Let's conclude this afternoon with the final talk given by Michael Haller from University of Bolzano. Michael Haller is the founder and head of the UniBZ's Media Interaction Lab. He comes from JKU in Linz, where he received his professorship. And after his habilitation in 2007, he started working there in his group and received lots of awards, like the Erwin Schröder Award, the Google Research Award, and the Microsoft Imagine Cup. So we can look forward to a talk where we try to bridge, let's say, wearables, sensoric topics into the automotive branch, only as a slight outlook. And I hope after switching between Microsoft and Apple, we are back online again. It worked during testing. So enjoy that talk. Thanks for being here.
Thank you. Thanks for having me. So actually, in the next couple of minutes, I would like to give you a short overview of what we did in Austria and also what we are doing right now here at Bolzano. As you heard before, originally I'm from Merano, but then I moved towards Austria for almost 30 years. And I was for 20 years at the University of Applied Sciences in Hagenberg. And there I founded the lab, which is called the Media Interaction Lab. And Martina said actually that she's the outlier here, but actually I think I am, because my background is actually in computer graphics. So in the past, or in my first decade, I did virtual reality applications and also mixed reality applications. What you can see here are devices which are outdated. So this was the iPad. So some of you might notice this device. So this was a long time before the iPhone came out. And nobody realized that augmented reality makes sense, so we did. And so actually one of the problems was that the devices were too small, they were not ready yet. And also the way of how to use HMDs didn't work out. And so we moved towards another topic, which was developing really large surfaces. And so we did for a very long time, we wanted to develop the office of tomorrow. So going beyond what we had in 2004. And so we started developing large interactive surfaces. And then we had a problem because the iPhone came out. And in our case, it was that we were primarily interacting with digital pens, as you can see in this video. And this was a problem for us because everybody requested for a multi-touch device, but this wasn't possible at that time. And so together with UNM Research, which is an institute quite comparable with the STL, we worked together on developing a piezoelectric sensor. It turned out that this device was quite neat because you could also bend it. And so we worked together with UNM, but also with Microsoft Research on developing the next generation interface. And so we implemented on the surface a substrate, which is similar to what Martina is doing, but on a piezoelectric sensor. And we started doing more and more on sensing. And then we asked ourselves, what about the next step? Would the Textile be a good input device? And we are privileged to work with a well-known German car manufacturer, BMW. And I don't know how many of you have seen this car. So this is the Neue Klasse, which is the brand new BMW coming out in 5 years. This car is built on a concept car, which is the BMW D. So this was announced this year at CES in Los Angeles. It made a lot of rumors because it could change its exterior in real time, so you could change your color. But then if you dive deeper, you will also notice that the interior is completely changing. So BMW is trying to make a really radical change in their car. And if you look closer, you might see that, that everything is disappearing. So actually, you don't have even a display in front of you. The display becomes your windshield. And you have a head-up display, which is going beyond what you have right now. And if you look closer, then you might see that the only interface which you have now is just the steering wheel
as well as some controllers which are based on textiles. And the reason behind this, because BMW, but also other car manufacturers like Volkswagen, they are trying to remove all the plastic controllers which we have nowadays. And one of the problems is that although you just see parts of it, most of it is hidden and it's super weight. So just this controller weighs about 300 grams. And in total, you have an electrical car which weighs about 1.5 tons, which is far too much right now. And this is a big problem. So the Cybertruck didn't work because it's too heavy. And most of the electrical cars are still too heavy. So if you compare, for instance, the ID.4 from Volkswagen, it weighs about 1.8 tons, which is like a diesel S-Class from Mercedes, which is insane in a way. And so what the car industry is focusing, they want to make the interior more smarter. And so we do it together with them. So we try to implement some applications which are purely on textile based. And our motivation is really to focus just on one single thing, which is a pressure sensor in the car. So our purpose was to make it so small that you can actually have a sensor inside of a thread. And so this is what you see here. So the sensor, I have one thread here. So this is the yarn which we develop. Can be sewed, it can be knitted, it can be woven, and it can be a pressure sensor. And the whole idea is to make this sensor so small that it can be projected into a yarn. So the way of how it's working is very simple, and the technology itself is very old. So it comes from the 70s. So everything in computer science is very old, by the way. And it's composed by a core, which is copper. So it's just a pure copper core. And then it's silver alloyed, so that we have more conductivity. And then it's coated by carbon polyamide. So this is quite similar to what Martina is showing, but we do that on a fiber level. And once you apply pressure on one of these threads, then actually we have a change of the resistance, which we can measure. We can make it very, very thin, so it's comparable to a hair. So it's very, very thin, and then we can also twist it and make it larger so that it can also fit into a knitting machine. And this is also one of our purposes. It should also be productive, and it should also work within an industrial machine. So in our case, we're using a Shima. So in our laboratory in Austria, we had the Shima machine, which is a flatbed knitting machine. And and then we are using just a thread, and then we can actually make a fabric. And the only thing we need is we need two cores, or two of those threads, which are intersecting to each other. And once you apply a pressure, once you apply a force, they're intersecting to each other. And this is a change, and it's also a change in the resistance, which you can then measure. And here we also have the demo here, if you want to see it in live. Once you apply a pressure on one of these threads, then you can see it also on the screen here that there is a peak, which implies that there is pressure applied on that spot. At the end of the day, I'm just showing here functional prototypes because unfortunately the real cool demos are at BMW. So we can also make it larger with a knitting machine, so we can really make patches, so we can really scale it up. And at the end of the day, we would also have haptics in the textile, because that's the nice thing about textiles. We don't want to touch or slide over a piece of glass, which we have right now on a touch screen, but we would like to have also the affordance of haptics, because this makes it so special. And this brings me to the next thing, because once you knit it, you can also make 3D structures, and this is very, very nice. Together with Coplater, which is a well-known knitting company in Upper Austria, we were experimenting different kinds of 3D structures, and the overall goal is to eliminate the foam, because that's one of the biggest problems now in the automotive, that the foam is wasted, especially in the production process, and not just once you use it, and this is a big problem. And if we would be able to make a 3D structure, and if we could combine it also with some sensing, then I think also we as a consumer would accept it, because the problem with sustainability is that the customers always want to have more functions. They don't care so much about about sustainability once they miss the functions. That's the biggest problem. But once we reach that, so that we can also add, for instance, a pressure sensor in a knit form, then I think we are there. So I show you some examples here, because these are the prototypes which we developed, but you can also imagine that you can scale it up. This is a pressure sensor which is coming out from the knitting machine in once. Or here you can see that we also get real-time feedback, so you can imagine that you can also have this in the car seat. And we can also do some 3D deformations, so you can imagine that we have a new textile-based controller for a virtual reality application. What's next? I was coming here to Bolzano, and then I discovered a very, very, very nice person, Professor Nico Münzenrieder. He's a physicist, so he knows much more about physics than I do. And he has a very, very nice machine, which is this machine here, which is a sputtering machine. And what we can do there is, imagine that you have a surface and that you have a kind of material like copper or gold or silver. Then with an electrical, actually with a plasma beam, he's beaming directly on the copper, and then the particles, the atoms, are directly falling to the substrate. And if you have also a silhouette, then you can really mask it out. And so what you can do is you can also sputter directly on a surface. And the really nice thing is that you can do that on a nanostructure, which means that you can make really, really tiny and really, really small sensors. And the very nice thing is that you can do that on any arbitrary material, like on stone. And what we do now, we are sputtering electronics and sensors directly on a single thread, which is invisible for you because you cannot see it, but we can sense it. And this makes it very, very unique. This is a demo Carlos did, who is also in the audience here. So this is his temperature sensor, and as you can see, it's a proof of concept which is working fine. So there's no fake here. So this is a temperature sensor directly on a thread with 80 millimeters of radius. And at the end of the day, and this is always what we want to have this monofilament which is also interwoven into textiles or knitted. So what is the outlook? Just 2 weeks ago or 3 weeks ago, I got a big award here for setting up an infrastructure in smart textiles, which is awesome for us. So here at the Neu Tech Park, we will get a really large laboratory with knitting machines, professional knitting machines, which is awesome for computer scientists, of course, because we can program them. And so we can actually produce and mass produce really and scale up also the things what we started in Austria. So we can really make textiles, we can make them, we can actually enhance them also with fibers which we are developing. And we also want to go towards wearables because we have some ideas already where to go. And this is, we didn't go there yet because it's always a challenge. And we heard it also today that it's a bigger challenge than in the automotive, but we would like to take this opportunity. Beyond that, we also will get an infrastructure to measure the sensors which we are developing. So we will get super microscopes which are then able to make renderings like this one here. And this is, of course, fascinating for us. Feel free to visit, collaborate, and join. We are looking for people, AR assistants, for companies to work with us. We worked a lot with the industry, as you have seen. So feel free to do so. As I told you, we will get soon a lab, which is even more impressive to what we have here. We also have a lot of things in the automotive domain, of course. And last but not least, I would like to acknowledge the companies BMW, KTM, Zephyr, and Tratter. So Tratter is also from South Tyrol. All the others are from Austria and Germany and Switzerland. And also to the EFRE, where we get the funding for the lab. So with that, I would also like to thank the Austrian team, and which is still there, but not so long anymore, because they're moving to South Tyrol soon, at least some of those. And thank you also to the students who are here, to Nico, and yeah, with that, thank you very much. I think I'm in time, and feel free to ask questions, and thank you very much.
Thanks for keeping the time. And I don't think that was all too much a topic of an outlier, since it's bringing things together which alters everything we are doing in future. So are there any final questions and remarks from the audience to Michael?
It's a very operative one, but you mentioned about the fact that you can produce with the machines you're getting at Neutech Park, textiles with sensors. On what scale? On prototype scale?
No. This was the purpose, really large scale. So this will become really a large industrial knitting machine where we can actually produce car seats if you want. So I don't know yet which machine we will order, but it will be the largest one.
But in terms of quantities, you do one machine?
This is an industrial machine. So so for instance, Coplater, I just know that company quite well. They are using the same machines to mass produce the Freischwinger from Team 7, for instance. Or they are making the seats for the DGV. So we can really make large-scale textiles.
Okay.
And also 3D structures. That's the nice thing. So we can do, for instance, this one is a small prototype, but we can also scale it up to a car seat or, yeah.
Okay, thank you.
And also garments can be produced in one step.
We continue here directly.
First of all, thank you.
I was asked Schima Stoll. I have a personal preference, which is the Stoll, because we have the Schima in Austria, so we have some experience with that machine. It's a little bit, it's too thin. So I mean, it's designed to be used for gloves, as you know, for the taxi drivers in Japan. To what we do, actually, we were working with Stoll as well. So we are working with Frank from Stoll directly in Germany. So we had a similar project what the keynote speaker at the beginning had from TCCV. So we had, ours was called Textile UX, and we were working with Volkswagen, KTM, Cephar, Coplater. Stoll was part of it, yeah. So we had a very similar one. But we more focused on knitting, I would say, while in Vorarlberg they're more focusing on weaving. And now I want to bring the knitting community together here in South Tyrol. Because it's really also tough in Austria. I don't know if you know the textile domain in Austria. It's also fighting, and the headquarters is in Vorarlberg. And in Upper Austria, all the companies disappeared. They are starting with hemp, though. So they are doing a lot with hemp. So Coplater, for instance, is doing a lot there. Yeah.
So first of all, thank you for your very interesting presentation. And my question would be, can this only be used for like car interiors or furniture, or would you think this is also possible for clothing, for example?
The reason why we started, because when we started the project, we were also thinking to do something together with Adidas, because we had a good relationship with Fantastic, and so we knew these people, but we didn't want to touch this at the beginning because we were not ready yet. So it takes a while to scale down the hardware. We have to think about washability. Now, in retrospective, our company, BMW, was really hard regarding the performance we had to address. So, for instance, they did 500,000 cycles of pressure on the textile, and then they said, well, the quality isn't that good as we expected after 500,000 cycles. So, washability is always an issue. So we did a lot of washing tests, chemical tests, but I think more challenging is wearables, because it also has to be comfortable. And we don't have to address that issue at the beginning. So I wouldn't say that we don't care, but we don't have to care so much as Saleva might do. Or like you have to do once it's a running t-shirt. So, but I think now we are ready. So we are ready to think about wearables, and might like to do it. Yeah, and we had a whole history. So we were working with the automotive quite for a while, and so we didn't want to stop. So it was a kind of normal thing. But yeah.
Yes, because my other question would have been, how is it about like if it's getting wet or if you're trying to clean it?
That's the problem we also have. So we have to care about washability because even I wouldn't say that the dashboard has to be washed, but even there you have the chemicals. And so this is what BMW does for a living. So they're just testing and destroying your material.
Okay, thank you so much.
Thank you. Further questions? Again, Christine.
You showed this yarn printing with this splatter machine.
Yeah.
Is this a trial, or did you already
actually
realize yarn?
This is a monofilament which is coming from Sapphire, so from Mono-Swiss. So Mono-Swiss is making monofilaments, and if you're getting a spool, then it's like this. And this is now just a small piece because one of the problems which we have is the sputtering machine has a limitation of the size there.
That was my question, if you could continuously sputter.
But the next step, hopefully, will be that the next yarn should have a length of 80 meters. And then we want to scale it up because it should really go to a weaving machine. And the tests which we have to do right now is which material is optimal so that it doesn't get off. And we don't think at the beginning at scalability, but yes, of course. Here, in this thread, for instance, we can make 3,000 kilometers, whatever. So this is a product now. It can be a product. So the outcome of this project was just this. but yeah, for the company, this is now a new product. This is not done by us. At the end of the day, this is fabricated by a Electrisola, which is also located here in South Tyrol. But the people we worked with are from Switzerland because they can make it really, really thin. So it's super thin. It's about 50 micrometers in the core. And with the coating, it's about 80. But this is, generally speaking, a very important issue for us to scale it up so that it can become a product and that it can be used in the car or wherever.
Thank you, Michael.
Thank you.
Maybe if you just stay here, and I invite all the speakers here above to the podium to take a final picture before we close up this event. Thank you, the audience, for being here today. Thank you for the time and for the discussions you've invested here. And due to that, I would also like to invite you to go over there with us to Neusteria, where an aperitivo is already prepared for you. So take the time to join us there for a small drink and a little bit more of discussions. I would like to thank all the people involved in preparing this event of today. First of all, the group of Automotive Automation with Johannes Brunner and Jakob Niederbacher preparing that. The events organization team of Iris Cretelli, Lisa Geier and Veronika Adami. And the guys from in-house meeting management, Verena Zublasing and Stefan Wieser, who did everything behind the scenes for sound and for recording. Recording. Please don't forget, this event has been recorded. So I think next week, on Monday or so, you will receive an email with a link directly to YouTube, which you can share with all your community so everybody who could not be there here today can join virtually. So, thanks again for being here and join us in Neusteria.